Hey everyone, welcome to my channel. In this video, I'm going to explain to you Ethereum, blockchains, how they work, and most importantly, why this is going to change the internet as we know it today. On the Ethereum website, Ethereum is described as a technology that lets you send cryptocurrency to anyone for a small fee. So let's take a look at that sentence and break it down. If we take a look at blockchain as a concept, if you want to send a transaction from point A to point B, you have to go through what's called a blockchain. And that blockchain is something that is maintained by what's called a miner. That miner makes sure that the blockchain acts the way it does to send the money from point A to point B as it should. Now let's take a look at how the theoretical idea of a blockchain is implemented on the Ethereum network. If we take a look at this website, which I find really helpful in understanding how blockchains work, I will put the link to the website in the description, but there are some videos by Anders Brownworth where he describes blockchains in great detail. Now, a block is a collection of data that is verified using its hash, and the hash is a very unique number that identifies the data. So, as the data changes, you're going to find the hash number changing as well. Now, if we take a look at the blockchain, we see that there is block 1, 2, and 3, and all these blocks are connected together. If we take a look at each block, we can see that each block has a previous hash of the block that is before it. So what happens if we change the data here? Now we can see that all the blocks are invalid, but what is the reason behind that? Well, the reason is this hash number actually has to be less than or equal to a certain number that identifies this block. Now that hash value that we see is a hexadecimal number that we can't really quite identify what that number is. So what we need to do is to change that number to something that we can read. Now, if we convert that number using JavaScript, we can see what that number is. So we actually see that this is a huge number. So why would that be important? Well, this is important because, like we said, the hash number must be less than or equal to a certain number for this block to be valid. So what we want to do is we want to mine the block. So what we refer to as mine the block is we keep changing this nonce value into something that generates a hash number that is less than or equal to what we want. Let's take a look at how that works. Now, as you can see, this took some time to generate a number that works for this block, but we end up having the other blocks as invalid because we changed that block in the first place. So now what we're going to do is just mine the other blocks as well to change their hash values. As you can tell, this took quite some time to do, and this could be a very tedious process, but this is what we refer to as mining. Basically, we just change the nonce into a number that generates a hash that is less than or equal to something that we want. Well, now going back to the previous diagram, we can kind of understand what a miner really does in this case. So a miner is someone who uses his or her computer power to fix the hash value for the blocks so that all the blocks are interconnected, and that way you can send a transaction from point A to point B. Now, what's really cool about Ethereum is that you don't just send transactions on the blockchain. You can also add what's called a smart contract on the blockchain, which is a very unique idea that was introduced in 2013 in the Ethereum Whitepaper. Now, if we take a look at the Ethereum Whitepaper, we can see that something new was introduced in here, which is referred to as the proof of work. Now, that proof of work is the idea of having the mining process to keep the blockchain interconnected. Now, like I said, the unique idea that Ethereum introduced was the smart contracts. Now, smart contracts are a bunch of code that live on the Ethereum blockchain, and they help you interact with what is called decentralized applications. Now, the way the smart contract works is you interact with something called ABI on the smart contract, and the ABI interacts with the bytecode. So just think about that as a bunch of code that lives on the Ethereum blockchain. And if you were to grab data from that smart contract, that is completely for free. But if you were to change data or send data, that costs what's called gas. Now let's discuss what gas is by breaking down how Ethereum as a cryptocurrency works. As we can break down the US dollar into 100 pennies, we can also break down one Ethereum as that many G-Ways. And the gas would be the cost that is necessary to process a transaction on the blockchain. The price of that gas is determined by the supply and demand on the token. If you set a gas limit of 400 for a process that's going to take 1,000 gas, probably that process is not going to work because you set the gas limit to whatever number that you set it to, and that number that is required by the smart contract is going to exceed that limit. The reason for that is because the gas price for every line of code is different. In addition, operation in a line of code will cost, for example, 3 gas, and that cost does not change, but the gas price does change. As we described, it's based on the supply and demand. So to get the total transaction cost, you multiply the gas cost by the gas price in GWAG. That money that you pay actually goes to the miner that uses his or her electricity and computer power to mine the block that you're doing the transaction on. Now, as a summary of what we discussed, if you were to send data or process a transaction on the blockchain, you would have to add that data to a block, and a miner would mine that block to generate the hash value that is needed for that block to be valid. And smart contracts live on the blockchain. Now let's discuss what Web 3.0 is, because we've heard that a lot recently. Now, to discuss Web 3.0 is, we have to understand what Web 2.0 is in the first place, and that is the web that we use today. So the way the web works today is you send data from point A to point B through what's called a server, and your data lives on that server. Not just your data, but also the code that is used to transfer that data lives on that server as well. That code is most probably going to be something that is closed source, which means you cannot access the code to see what it does with your data. And as you can tell, that probably doesn't sound very safe. But going back to the idea of Web 3.0, the difference is you can actually see the code that lives in the smart contracts on the blockchain. And when I mentioned that the blockchain is open source, I mean that you can access every transaction that happens on the blockchain in real time, as you can see right here. Now we can see that the smart contract is a great idea that is going to change the internet as we know it today. So the way you would interact with applications, we refer to them as decentralized applications. These apps, they use what's called the smart contract that we have discussed. Now I believe that there's going to be a huge competition in decentralized apps, as each line of code is actually going to account for some amount of money, and that's going to open the door to optimization of code, and you can consider that with time complexities and other things as well. Thank you guys for watching this video, and I hope you enjoyed the content. As I speak today, Ethereum are planning on moving into something new, which is called the proof of stake. What we described today is called the proof of work. Now, if you would like to learn more about proof of stake, just leave that in the comments. I will make a video in the future if that's something that you would want to see. And don't forget to smash that like button. I'm just kidding. See you in the next video.